Very good morning, students. We will start this chapter calorimetry and we will know about the concept of heat and temperature. So what is heat? Heat is the total internal energy of a body. So what is the total internal energy? Here the sum of kinetic energies and the sum of potential energies of the constituent particles of the body gives the total internal energy. Let's see how. Suppose this is a body. In this volume of this body there are many molecules present and each molecules are in random motion. That means the molecules are in random motion, and due to their motion they have kinetic energies. And as because the molecules has the intermolecular attraction, so in due to this they have some potential energy too. Okay, and the sum of the kinetic energies and the potential energies of all those molecules gives the total internal energy, and this total internal energy is considered as the heat associated with this body. Correct. Now one more line, that heat always flows from a body of more heat to a body of less heat. Suppose two bodies are in contact, one body has greater amount of heat, then this body loses some heat to any other body which has less heat. Correct. Now see, what is the unit to measure the heat? See, as heat is a form of energy, so it has the same unit as the energy has. So joule is the SI unit of heat. Now the commonly usable unit is calorie for the heat. So how we will know about calorie? So here 1 calorie, first we will know about 1 calorie. 1 calorie is the quantity of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. So that means if we want to give some heat to 1 gram of water, so that its temperature is raised by 1 degree Celsius, then we will say that that amount of heat is 1 calorie. Correct. Suppose, okay, here this is the precise definition, as here we are considering that the drop of water, that is the drop of water 1 gram, is at the temperature 14.5 degrees Celsius and it is raised to 15.5 degrees Celsius, that is raised by 1 degree Celsius. Correct. So here see, from this picture heat is given to that drop. This is 1 gram. Okay, this is 1 gram of water at 14.5 degrees Celsius, and some amount of heat is given, and that amount of heat is 1 calorie. And as this heat is given to that drop, now its temperature is increased by 1 degree Celsius and it reaches to 15.5 degrees Celsius. So here we have the precise definition. 1 calorie is the heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius, that is it is raised by 1 degree Celsius. Correct. So here suppose as this one is 1 calorie, suppose if you want to know about 2 calorie, then we will say that it is 2 gram of water. So if it is 1000 calorie, that means 1 kilocalorie. Okay, then we will say that it is the heat required for the water, for the mass of water of 100 gram, 1000 gram, that is 1 kg of water, to raise its temperature from this 14.5 degrees Celsius to 15.5 degrees Celsius. Correct. Now see, what is temperature? What is the concept of temperature? Here temperature is a factor that determines these two. The first one, the direction of flow of heat. Okay, direction of flow of heat from a body, as because the heat always flow from a body has heat in greater amount to a body has a less amount of heat. Correct. So here this temperature determines the direction of flow of heat, that means which body has greater heat and which body has lesser heat. And the second factor, that the temperature determines that the extent of heat a body has, that means what is the extent of heat a body has, that can be measured by this temperature. Correct. Suppose here we have a hot body, then its temperature is high as because it has excess heat. Suppose we have a cold body, then the temperature is low as because it has less heat. Correct. Now see, these are the two bodies, this is hot body, this is cold body. Suppose those two are in contact, then as I said that heat is always flow from a body at which has greater heat energy. So here this body has greater heat energy, so that's why the heat will start to flow from this body, this hot body, to the cold body. Correct. So here we have a definition of temperature. The temperature is a parameter which tells us the thermal state of the body, and it is also defined as the degree of hotness or coldness of the body, and it will also determines the direction of flow of heat. So one more point is given here, the important point, that no flow of heat between two bodies at same temperature. Suppose if you consider any two body, and suppose here if you consider these two body, when the hot body started to give heat to that cold body, then at a certain instant, at a certain point, at a certain time, those two body has same temperature, that means has same amount of heat, correct? Then we will say that there is no any, if those two has same amount of that means if those two has same temperature, I'm telling, if those two body has same temperature, at that time there is no any flow of heat from any body to any other body, correct? So this line, see the last line, no flow of heat in between two bodies at same temperature. Now what is the unit of temperature? So as we know that degree Celsius is one of the unit of temperature, and in SI the unit of temperature is Kelvin. Temperature is one of the fundamental unit, and its SI unit is, temperature is one of the fundamental quantity, and its SI unit is Kelvin. So here we have degree Celsius and Kelvin, those are the two units. So how we can relate those? See at 0 degree Celsius, see here 0 degree Celsius is equal to 273.15 Kelvin, which is nearly equal to 273 Kelvin, correct? That means if we have a temperature 0 degree Celsius, then it can be written as 273 Kelvin, correct? Suppose there is a change in temperature, that means the temperature is increased or decreased by this value, that is 1 degree Celsius, correct? Then we will say that this is the equal, that means 1 degree Celsius change is equal to 1 Kelvin, correct? As because here if I say that the temperature is raised by 1 degree Celsius, then from 0 it will reaches to 1 degree Celsius, 0 plus 1, that is 1 degree Celsius. So here this Kelvin, in the Kelvin scale, it is 273 plus 1, that is 274 Kelvin. So in the same way, if this delta T degree Celsius is the change in temperature in degree Celsius scale, then in the Kelvin scale it is same, that means it is delta T degree, that means delta T Kelvin, that is the change in is same. Whatever the numerical value that we are taking here for in degree Celsius and in Kelvin, those are same, as because in degree Celsius whatever the change is made is same as in Kelvin, correct? So change is same in both the unit. That means suppose if we are saying that a temperature is changed by 50 degree Celsius, a temperature is changed by 50 degree Celsius, then we will say that, we can say that this temperature is changed by 50 Kelvin also. So change of 50 degree Celsius is same as change of 50 Kelvin, correct? Now here this temperature T in Kelvin scale, it is written as 273 plus T, correct? And here this small t is actually the numerical value in that used in degree Celsius scale, correct? So here in the last, here T is the temperature reading in degree Celsius, that means the value, the numerical value, that is the reading in degree Celsius. Suppose we are saying that 37 degrees Celsius, so in Kelvin scale it will be 37, that means 273 plus 37, correct? And it will be, just add those. Now see here the factors that affect the quantity of heat absorbed by a body. So here I have missed to write heat, so it is the factors that affecting quantity of heat absorbed by a body, that is either solid, liquid or gas. So first factor is the mass of the body. If Q is the quantity of heat absorbed by a body for a fixed raise in temperature, that means if it is the temperature is raised by T degree Celsius for a body, then this Q is completely depend on the mass of the body. Suppose if the mass is greater, then for this raise in temperature, first this T degree Celsius raise in temperature, we have to give a heat Q which is greater. If the mass is lesser and we want to raise the temperature by this T degree Celsius again, then we have to give less amount of heat. Correct. That means whatever the mass, it is completely depending on that means whatever the heat is given for this raise in temperature, for this T degree Celsius raise in temperature, it is this amount is completely depending on the mass of the body. So we will say that Q, that is the amount of heat given to the body or absorbed by a body for this raise in temperature, it is completely depending on the mass of the body. Greater the mass, greater the heat required, and lesser the mass, lesser the heat required for the same change in temperature, for the same raise in temperature. Correct. Now the second factor, if we take the mass constant, that means we are considering that two bodies of same masses, two identical bodies, same substance, same masses, and if we want to raise the temperature in different value, that means here the factor, the degree of raise in temperature. What is the degree of raise in temperature? In this factor, the quantity of heat given to that body is also dependent. Correct. So that means I want to say here that if the temperature of the body of mass m, that is constant, is to be raised by a degree, this delta T, okay, then this Q, the amount of heat given to that body, is completely depending on the change in temperature. Suppose if we are raising the temperature by any value, take any value 15 degrees Celsius for the mass m, then we have to give some heat 15 degrees Celsius for the raise 15 degrees Celsius. Suppose if we want to raise the temperature by 30 degrees Celsius, then we have to give more heat, greater heat, as the increase in temperature is initially 15 degrees Celsius, and now we are saying that for the same mass we want to increase the temperature, we want to raise the temperature by 30 degrees Celsius. That means the change is double. From 15 degrees Celsius we want that initially it is, the change is 15 degrees Celsius, now we want to change the temperature by 30 degrees Celsius. So the degree of raise in temperature is double. So we will say that here we have to give the double amount of heat. Correct. That means the double quantity or double amount of heat is absorbed by that body for that raise of temperature. Correct. So we will say that whatever the degree of raise in temperature, the quantity of heat absorbed by the body is completely depending on that raise of temperature. Suppose if we take the mass constant. Now see the third factor, the type of substance of the body. Here the type of substance of the body means, suppose if we are saying that the body is of same mass and we want to raise the temperature by same degree Celsius, that means the raise in temperature is same. Correct. So here see this line, if two bodies of different kind, that means of different substances, are of same mass and Q1 and Q2 are the heat absorbed by those two bodies to raise their temperature by this T degree Celsius. That means for both the body the temperature is raised by T degree Celsius, delta T degree Celsius, and both the bodies are of same mass m. Then this Q1 and Q2 are different values. Why? Because they are different substances. Okay, and they are different substances of same masses, and the raise in temperature is also same, but as those two are of different substances, so the quantity of heat absorbed by those two is also different. Correct. So here the heat, that is Q, absorbed by the body for the raise of temperature, it is depending on the substance of the body. So this is the third factor. Now see, the overall conclusion is that this quantity of heat is directly proportional to mass, it is directly proportional to degree of raise in temperature, and it is direct, that's why by combining those two factors, as because this is see the third factor, it is also depending on the substance of the body, but here we can't write this one mathematically, so we combine those two factors and we will say that the quantity of heat absorbed by a body, it is depending on the mass, and it is depending on the product of mass and the degree of raise in temperature, that is m into delta. Now if we remove the proportionality sign, then we will put this we will put this proportionality constant. So here see this C is the proportionality constant, and we have this Q equals to C m into delta T. Correct. And the C is actually the proportionality constant, and it is called the specific heat capacity of that substance, and for that means we will know about this specific heat capacity in the next point. Okay, now say I am changing the page. We have the difference of heat and temperature. The difference is given in the book, so I am just introducing some of the factors. Like here, suppose these are the two bodies, and from the picture you can easily understand that one of the body has heat H1 and another has heat H2, and the temperature of the first body is T1 and for the second it is T2. So suppose if we are considering that H1 and H2 are same, that means both the bodies has same quantity of heat, same amount of heat, but their temperature are different. We are considering only that the heat of those two bodies are same, like here as I have written H1 is equal to H2, that means those two has same heat. Then we will say that, as from the picture you can easily understand, this body is smaller as compared to this. So if those bodies are of same substances, same kind of bodies, then this body has greater mass and this body has lesser mass and this body has greater mass. Then we will say that as those two have same heat, we will say that the temperature of this one is greater, T1 is greater as compared to T2. Now the question arises why. So here the answer is, in the first body the molecules are moving fastly, as because there is very less area. Okay, and this heat H1 is because of this molecules. Okay, and the molecules are possessing a greater kinetic energy in the first body. Now see the next page. Heat in a body is the total internal energy of the molecules present in the body. Total internal energy, and this total internal energy is due to the potential energy as well as the kinetic energy of the molecules. Correct. So here what I said, that here the molecules has greater kinetic energy, so that's why heat is greater. In a smaller mass, in a smaller mass the heat is greater. Now here see this line, I am reading this once again. Heat in a body is the total internal energy of the molecules present in the body. Depending on the mass of the body, the number of molecules depending on the mass of the body and the number of molecules, the heat associated with the body is determined. Correct. So here if the number of molecules is greater, we will say that the heat is greater, the heat associated with the body is greater, as because the molecules has greater kinetic, that means molecules has kinetic energy. If more molecules are there, then their kinetic energy is added and the internal energy increases. Correct. So we will say greater amount of heat associated with that body with greater mass. Now see the temperature. Temperature is the heat distribution throughout the mass of the body. Correct. So here we will say that depending on the average kinetic energy of the molecules. Average kinetic energy. If the number of the molecules increases, we will consider again, that means we will consider only the average kinetic energy. Okay, average kinetic energy of the molecules. If the numbers of molecules increases, if the mass is increases, we will consider only the average kinetic energy of the molecules, and this gives the temperature of the body. So that's why, suppose if we have this bigger body, here in every section the average kinetic energy for the molecules is lesser as compared to this. So that's why this body has greater temperature and this body has lesser temperature. Correct. Now see that this one, heat and temperature of a system of bodies. This is the system of two bodies are there, and from this picture you can easily understand this has the temperature T1 with the heat H1 and this one H2 with the temperature T2. So total heat of that system is given by the sum of the heat. So here H1 is the heat, here H2 heat. So if we add those two heat, we have the total heat of the system. So the total heat of the system is H, which is the sum of the individual heat associated with the individual body, the sum of heat associated with the individual body. Now what is the resultant temperature of that system? Suppose if we made those two bodies in contact, then yeah, the heat will share, the heat will transfer from one body to another body. So overall we will say that the resultant temperature of the body is actually the average of temperature. That means here this resultant temperature is 1 by 2 of T1 plus T2. Here we will understand that suppose those two bodies are in contact, then this temperature T1, suppose this T1 is greater, then this T1 from this body, some heat will transfer to that body up to that instant when those two bodies has same temperature. That means those two the temperature of the bodies reaches to a same value. Okay, and as after transferring some heat, when both the bodies has equal temperature, when both the bodies reaches to equal temperature, then there will be no any transfer of temperature, no any transfer of heat. So we will say that what is the temperature, what is the temperature? So average value is the temperature. So 1 by 2 T1 plus T2 is the resultant temperature of that system. So this completes